when you grab a bottle of pills, you don't even, you trust they're safe and effective.
Right.
Today's deep dive takes us way behind the scenes of that trust into a world most people probably don't even think twice about, the world of pharmaceutical manufacturing and something called steam sterilization. We're talking about the incredibly stringent processes that make sure that the medicines we rely on are made with equipment that's 100% free from any trace of bacteria.
Yes.
And you've sent over some fascinating material about EN285 steam quality testing.
Right.
What is this EN285 and why does it sound so important, especially when it comes to something called PICS GMP?
Great question.
Yeah.
You've hit on a very crucial aspect of pharmaceutical production. So picture this PICS GMP. Think of it as the global rule book for pharmaceutical manufacturing, essentially ensuring that every medicine, no matter where it's made, meets the highest safety and quality standards. And within that rule book, steam sterilization and, by extension, EN285 play a critical role. EN285 is a European standard, specifically focused on large steam sterilizers. So these are really the workhorses of this process. They use superheated steam to eliminate bacteria from equipment.
So these are like intense pressure cookers, but instead of making soup, they're sterilizing medical equipment.
You're exactly right.
I'm guessing this isn't your grandma's pressure cooker, though, right?
Yeah. No.
Why all the fuss about the steam itself?
Yeah, you've hit on another key point. The steam used in pharmaceutical manufacturing is held to unbelievably high standards. And it makes sense, right? If the steam isn't right, the sterilization process may not be effective, potentially jeopardizing the safety of the medicines we rely on.
Yeah, that makes sense. But what makes for good steam in this context? What's so special about it?
Good point. That's where EN285 steps in. It provides very specific criteria for steam quality. It really zeroes in on three key things: how much air is in the steam,
Okay.
how much moisture is in the steam, and how hot the steam actually gets. And these parameters are known as non-condensable gases, dryness, and superheat, respectively, and they directly impact the effectiveness of the sterilization process.
Hold on. Even a little air matters in this high-stakes world of sterile medicines.
Absolutely.
That seems wild. And what's the deal with superheat? Isn't hotter always better when it comes to killing bacteria?
You would think so, right? But it's a bit more nuanced than that. Let's break down each of these parameters and you'll see why they're so crucial.
Okay, let's unpack this, starting with those sneaky air molecules. Why are they a concern in the steam?
It all boils down to heat transfer. You see, these non-condensable gases, primarily air, act as insulators. And even a tiny air bubble can create a protective barrier that prevents the steam from properly reaching and eliminating every single bacteria.
Oh, wow.
Imagine trying to bake a cake and you have that soggy bottom.
Right.
Because the heat's not transferring properly.
Right.
You end up with a less than ideal result. Same principle applies here. Even a small amount of air can compromise that entire sterilization process.
Wow. So even a tiny air bubble could mean the difference between a sterile instrument and a potentially dangerous one.
Absolutely.
That's a pretty powerful illustration. Okay, next up, dryness. Is that as straightforward as it sounds?
Pretty much. Dryness measures how much water in the form of tiny droplets is mixed in with the steam. The goal is to have as close to completely dry steam as possible.
Okay.
The drier the steam, the more effectively it transfers heat and eliminates bacteria. Wet steam, on the other hand, has less energy to transfer.
Okay.
Imagine trying to dry something with a damp towel versus a bone-dry one. That dry one will absorb the moisture much more effectively.
Right.
And it's the same principle with the steam.
Okay, so it's like the steam needs to pack a powerful punch of heat, and any excess moisture is going to weaken its impact.
Exactly.
Got it. What about superheat? Why is hotter not always better in this case?
This one often throws people off.
Yeah.
Superheat refers to steam that's even hotter than its boiling point at a given pressure. So while incredibly hot superheated steam doesn't release its heat as efficiently as saturated steam, which is steam that's at its boiling point.
Interesting.
It's kind of like the difference between trying to bake something in a dry oven versus one that has like a pan of water at the bottom. Both are hot, but that moist heat transfers much more effectively for baking.
Right.
In this case, for sterilization, you need that effective heat transfer to ensure those instruments are truly sterile.
Okay, this is all making sense, but it's clear this isn't as simple as just blasting some hot steam around.
Yeah.
We've got to make sure it's the right kind of steam meeting those EN285 standards.
Yeah.
But how do we even know if the steam measures up? How do they actually test for all of this?
Ah, that's where things get really interesting. Remember that company you mentioned, Thornen?
Yeah.
They're experts in EN285 testing, and they've developed some seriously cool tech to ensure that pharmaceutical companies are producing top-notch steam.
So they're like the steam police swooping in to make sure everything's up to code.
Yeah, in a way.
Tell me more about their approach. What does this high-stakes steam inspection look like?
Well, it starts with getting those measurements just right. For non-condensable gases, they use what's called an air-cooled condenser.
Okay.
And this device essentially takes a steam sample and very carefully condenses it, separating out any air that's snuck in. By measuring that separated air, they can determine if it's within the acceptable limits set by EN285.
Mm.
It's all about precision and making sure those measurements are spot on.
So it's like those tiny air molecules are trying to pull a fast one,
Mm-hmm.
but Thornen is one step ahead.
Exactly.
What about dryness? How do they measure something that seems well invisible?
They've got that covered too. Thornen uses a method that very precisely measures how much steam is needed to heat a specific amount of water to a precise temperature.
Okay.
And by analyzing how much steam is required, they can determine what's called the dryness value, essentially how much of that steam is pure steam versus those tiny water droplets.
So it's all about understanding those energy dynamics. How much heat is being transferred and whether any of that sneaky moisture is getting in the way. It's amazing how they've managed to measure something as seemingly elusive as dryness with such precision.
It's pretty incredible.
Okay, last but not least, superheat. How do they tackle that one?
For superheat, they actually use a pretty clever trick involving a pressure reduction. They'll compare the steam's temperature before and after it goes through a pressure drop. And this helps them to figure out if the steam is hotter than it should be at that reduced pressure, which would indicate superheating.
So it's like a steam obstacle course, putting it through its paces to make sure it's up to the task of sterilization. It's remarkable how much detail goes into something that seems so simple on the surface.
Yeah.
But knowing that these processes are in place, that companies like Thornen are meticulously testing and ensuring steam quality, it's pretty reassuring.
Absolutely. And what's even more reassuring is that Thornen doesn't just point out the problem. They're all about finding solutions. They'll work closely with these pharmaceutical companies to address any issues and ensure that their steam systems are operating at peak performance.
So they're like steam quality detectives, but also steam system therapists.
Yeah.
Helping those systems be the best that they can be.
Exactly.
What kinds of services do they offer to get these systems in tip-top shape?
Well, it all starts with a thorough assessment of the entire steam system, from the equipment generating the steam all the way to the autoclaves where that sterilization happens. They call this a steam system audit. It's like giving the entire system a comprehensive checkup.
So they're looking at the big picture, not just individual components in isolation.
Exactly. And this allows them to pinpoint any potential weak points in the system, whether it's a leaky pipe that's causing condensation, or a faulty valve that's throwing off the pressure, or even a poorly designed distribution network.
This is fascinating. It's like those home renovation shows where they uncover all the hidden problems behind the walls. You never know what you'll find until you start digging deeper.
Precisely. And once they've identified any potential issues, they don't just leave those companies hanging. Thornen then provides tailored recommendations and solutions to address those specific problems. It might be a simple adjustment like tweaking a valve setting or improving insulation, or it could involve more complex modifications to the system's design or equipment.
So they're not just diagnosing the problem, but they're also offering a treatment plan to get that steam system back to its prime.
You got it. And this is crucial because for pharmaceutical companies, time is money, literally. Any downtime in production due to steam system issues can be incredibly costly. By proactively addressing those issues, Thornen helps to ensure a smooth and efficient manufacturing process, meaning that those life-saving medications can continue to be produced without a hitch.
This has been a real eye-opener. I never realized just how much complexity and meticulous attention to detail goes into something as seemingly basic as steam, let alone its critical role in something as important as pharmaceutical manufacturing.
It's one of those hidden worlds that quietly impact our lives in profound ways every single day. Companies like Thornen, with their expertise in EN285 steam quality testing, are the unsung heroes, working tirelessly behind the scenes to ensure that the world operates safely, effectively, and reliably.
It really makes you appreciate all the effort that goes into ensuring that those medicines that we rely on every day are safe and effective. It's like a whole other level of scrutiny and precision that most of us never even think about.
Yeah, and that's the beauty of these deep dives, you know? We get to uncover these hidden worlds and shed light on this incredible work that's being done behind the scenes. In this case, it's about understanding that even something as seemingly simple as steam plays such a critical role in something as crucial as pharmaceutical manufacturing.
It really highlights that interconnectedness, doesn't it?
It does.
From understanding the physics of steam, to the biology of bacteria, to the engineering behind these sophisticated testing methods, it all comes together to ensure our health and well-being.
Absolutely. And the story doesn't end there. As technology advances, we can expect even more innovative and efficient methods for testing and maintaining steam quality.
Right.
Who knows what the future holds for this field?
Yeah, it's exciting to think about it. So for you listening, next time you take a prescription medication, take a moment to think about the incredible journey that it took to get to you. A journey that includes the often unsung hero of steam, meticulously tested and monitored to ensure those medicines are safe and effective.
Well said. It really is a testament to human ingenuity and our unwavering commitment to improving health outcomes.
This has been an incredible deep dive. I've learned so much about a world I never knew existed. Thank you so much for joining us today and sharing your expertise.
My pleasure. Always happy to talk steam.
And for our listeners, we hope this deep dive has given you a newfound appreciation for the hidden world of steam quality and its critical role in pharmaceutical manufacturing. Until next time, keep those minds curious and never stop exploring the world around you.